And they tried to solve this by the converters, digital to analog and analog to digital, so they are able to install the computer networks on the telephone network. At the beginning, everything was with wires and then moved to wireless, not the opposite way around. So everything started with wires, and then they start to use the wireless networks. So we start by the concepts, the main concepts here. The OSI reference model. If we want to talk about networks, so we have to start with OSI reference model. The OSI reference model is proposed in 1984, and it is initialized by ISO, International Organization for Standardization, and defined standards for communication protocols, as well as physical and logical interfaces between machines and subsystems. So the OSI reference model is mainly designed to have to design the protocols between communication between, for example, between computer A and computer B. Even right now, if you want to communicate with somebody, so you have to define some rules. For example, you have to say words and separate words by stopping, because if you say the words and letters together, the other party will not understand you. So whenever you speak to somebody, you are communicating with him. When you communicate with somebody, you are using protocols. We, as computer scientists, they moved the protocols from nature to the communication in the computer networks. So protocols is very important if you want to send something from one person to another, from one object to another. For example, if you want to send a package from city to another, there are protocol used to do that. For example, the package must be put on something that protects it from rain and from other weather conditions. And the sender name should be put on the package. Receiver name and address should be put on the package. All these are protocols. Without these protocols, you will never send this package from person A to person B. That's why the word protocols is there. So it is all about protocols. If you define these protocols, you will be able to communicate. Communication protocols. So OSI reference model is all about communication protocols, and they developed the OSI reference model to handle this. It is about a stack. A stack is like that, you know, just a stack, okay? And it contains the layers. If we like the word layers, is better to describe the OSI reference model. If you can see it here, this is the OSI reference model. It's all about layers, 7 layers. The first one from bottom to top is physical layer. The second one is data link layer. The third one is network layer. The fourth one is transport layer. The fifth one is session, presentation, and application. Let us talk about every layer in a nutshell. The first one is physical layer. This physical layer means the physical transformation of data from terminal A to terminal B. I'm sending electrical signals. So the sending of electrical signals is done in the physical layer. The data link layer is responsible to decode the data so it can be sent on the physical layer. For example, if I want to make sure the data has no or the frames has no errors, for example, I check I check the frames from errors in the data link layer. If I want to know the beginning or the beginning and the end of a fragment, so I can know that from the data link layer. It is all about preparing data to be sent on the physical layer. What about network layer? Network layer is responsible for finding the best path or the shortest route on the network. If a package is to be sent from A to B, so network should find the best path to send the data from terminal A to terminal B. For transport is responsible for making sure that the entire data is sent from A to B. I mean, maybe you can say network is finding the best path, but transport means I want to send the package, but this package is cut to pieces. Transport makes sure that it is sent at the sender and received and organized at the receiver. For the session is like if you open a session with a website, this is a process-to-process communication. Is maybe higher than transport layer, It is about session. You open a session. In this session, you send the data, you send username and password and so on. For presentation is a format for the data that you are sending. For example, you are sending HTML page, or you are sending encrypted data, and so on. For the application, the last layer here is the user interface, something you are seeing. For example, if you're sending a message on WhatsApp, so the text of the message is found on the application layer. Okay, so let's have an example. Okay, I have always a problem here. When I move to network subject and talk about OSI reference model, some students imagine that there are physically layers inside the computer. You think that some students think that layers are existing inside a computer in a place, physically existing. These layers, the 7 layers, what do you think?
Doctor, like I reflect on this.
Reflect what?
I reflect my opinion on it.
I can't hear you clearly.
Doctor, I reflect my opinion. Like, what do you think of all the layers?
No, I mean, some of the students, not you, of course, they think that the layers are existing in the computer. Layers. I mean, these layers, these 7 layers are existing in the computer. What do you think?
Doctor, it does exist, Doctor. It does, Doctor.
It does exist,
but we don't see them all. Like, you know, like the physical layer and the data link, the network, and all of these. What actually cares about them is the software engineers. They're the ones who are doing it. But there is only one thing that we see, which is the application, the user interface. Like, for example, this is something the user only cares about. Anyone who buys a phone cares about the shape of the phone. Like when they try the camera, they see how the megapixels. This is user interface. This is only what they care about. The presentation, the session, all of these, they don't care about it. They don't see it.
Yeah, this is called the abstract layer. Abstract means that you only see what you want to see. You don't care about the details.
Doctor, they actually don't know about this. The users don't know about this.
Yes.
It's not that they don't care. They don't know.
I mean, if you open a hardware, you will find layers, or software, you find layers like this.
No. You don't see it. You only see you're only an interface. You don't see all of this presentation, session, transport, all of this. You don't see it.
Okay. It's exactly if you have shipping company, okay? If you have shipping
Yeah.
company, yeah. So in this company, you have management, you have secretary, you have the drivers, the car drivers, okay? And
Yeah.
you don't actually, these layers is management layer, is not actual layers. It is just for management or for software, as you said, for software management. Is not actual, it is not existing as we can see it right now as layers as we can see it. For example, if you talk about the shipping company, the shipping company has drivers. The drivers don't know anything about management. They don't know even about the prices that paid for
Yeah. This is
transportation from A to
exactly.
B. So it's the physical layer is like that driver's layer. They just get the order to transfer a package from city A to city B. They don't care about the contents of the package. They don't care about the prices that paid for this package. They don't care about managing things. The other layers, the higher layers, they don't care about. They care only about their own job. They get
Exactly,
the
doctor. This is
package.
what I said.
Yeah, exactly. Yeah.
In the application layer and these stuff.
Yes, exactly. That's why I'm saying that it is not as you may think. It is, for example, if you open C++, for example, C++ code, you will not find a function for application and a function for present. No, it's not like that. There is no modules, or there is no hardware, there is no software. But if you can say some modules belongs to physical layer, some modules belongs to presentation layer, some
Yeah,
modules,
yeah.
and so on, like that. Okay, so that's why layers is like management layers. They separate the work between them. For example, layer at somebody in physical layer or some data or module in physical layer don't care about the internal structure of other layers, but care about the data transferred between itself and the upper layer, no more. For example, session layer just care about the data came from presentation layer to itself and whatever it sends to presentation layer, data going and coming back. And also for session layer, it cares about the transport layer for sending it data and getting data out from it, just like that. So this is the layers are very important in application in networking, to understand networking. And for example, here the data is created. For example, I can say I have a website page. I have a page on a website and I want to send this page from terminal A to terminal B. I will give you a detailed example. So for example, we have A here and we have B here. I want to send the data from A to B. Okay, the data is a web page.
Okay, doctor.
Yes, okay, so this is a web page and I want to send this web page from A to B. In the application layer, whatever I see, as you said, Abdullah, as you said, whatever the user is seeing, actually, this is at the application layer. This is the web page. At presentation layer, this is an HTML, okay?
Yeah,
HTML
okay.
means I prepare what is needed to send to be able to display this message from, or to display this page at B. For example, maybe I don't send everything. I need only the HTML code and some images. So presentation layer do this job, just to get only whatever needed to display the same page at the other terminal. Of course, this page is very huge. Maybe It contains many details, but all these details are not needed to display it again at terminal B. So presentation layer prepare this for displaying at terminal B. Then at session layer, we are talking about different HTML pages and different actions, different actions you are doing. For example, you are opening, you are having a form, and in this form you fill it and you submit it. You submit this. This is a session. The session contains HTML and other related session data. So this is prepared in the session layer. And the most important layer here is the transport layer. This is the actual preparation for transportation. This is done by segmenting this data to packages. Okay, and these packages is sequenced. I mean, it gets a sequence, for example, sequence number, just to make sure. For example, if this is a page and I want to sequence it, I can cut it to 4 pieces like that and say this is the first piece, the second piece, the third piece, the fourth piece. Why we do that? Just because I want to, it will be cut into pieces and will be lost in the network. But at the other terminal, it will be assembled back. How to assemble it back? Just using these sequence numbers. So the packages are, the page is segmented to packages, and these packages is serialized and sent to the receiver. At the network layer, it is responsible to take each package and find the best route between A and B and send this package through this route. It doesn't care about all the packages. It cares about one by one. It cares about them one by one, okay? The transport layer is responsible about all of them. Transport is looking at the entire packages, but network, it doesn't care about the entire packages. It cares about only one package. It wants to transfer it from A to B, just one package at a time. But network layer, it sees only one package level. Its level is to see one package, but at the transport layer sees the entire packages, the entire collection of packages. And then after sending it from, preparing it to be sent as a package, it gets to the data link layer to check it maybe at the sender, and at the receiver will check its error, and prepared for transportation using the physical layer. Maybe it will be transferred on a wired media or wireless media. According to this, we will do signaling and then send these packages from A to B. That's what happening inside the network. It takes the data from higher layers to lower layers and send it from A to B. And the transport layer is responsible for cutting the data into pieces at the sender and assemble the data back into assemble the data back at the receiver side. Okay, so we have therefore some people refer to 5 and 7. From 5 to 7, they call it application layer because it's all in the application layer. Whatever is done here, maybe it can be done in one layer, like the TCP/IP model, and then the data is transferred to transport layer and the network layer, and all of these also data link and physical, they are in one layer in the TCP/IP model. So 5 and 7, the layers from 5 to 7, you can consider them application layer. Layer 3 and 4, also 3 and 4 here, they are also correlated, network and data link. Okay, we can say that network layer, the most important thing in network is just to find the path, or find not broken path to send the data from terminal to terminal. And also this one, make sure that data is sent without errors, so that maybe they can couple together in one layer. Okay. Here, the most important thing, the functional lines between switches and routers now blurred. Means now, or before, we can say we have switches, we have independent functions, switches and routers. Now you find one device doing the same job. One device do the switching and router at the same time, and routing at the same time. So now you can see many switches can do routing job. For Cisco, now if you buy a switch from Cisco, it do the routing too. You don't have to buy another device for routing. Not all devices like that, but now they start to do this. They start to get the functions of routing and switching at the same device. Okay. So the main communication over a network, there are two main jobs: is conditioning the data for transport, or preparing data to be transported or transferred, and ensuring that data reaches the destination without any errors. These are the main jobs. Okay, so we talk about the application layer, so no need to repeat it again. For the Internet Protocol version 4, the Internet Protocol version 4, we can say we put IP number in dotted decimal format. What is the dotted decimal format? It is all having 8 bits or a byte at each point of these, and separated by points or dots. Because they are 8 bits, they can start from 0 to 256. From 0 to 256, not from 0 to 255, which is 256. Okay, so 255, from 0 to 155, all of these decimal or all of these octets can handle a number from 0 to 255. This is the dotted decimal. And of course, you know, these numbers is limited. These numbers are limited. It cannot cover the entire continent. It cannot cover the entire objects or computers, and whatever, anything need an IP, like routers, like switches, like printers, like Internet of Things, or your mobile device. Everything need an IP to be connected to the internet. So this this is dotted decimal is not sufficient. So they start to think about IP version 6. IP version 6 is higher than IP version 4. It can handle the zillions of data, okay? The zillions of terminals or devices. And also we have a network address translation. This is for IP version 4. IP version 4, we have NAT. What is NAT? NAT is to transfer the IP from local to public. For example, if we have, okay, let me draw something. If we have a company like that, the company here has the dotted decimal format. They have, for example, 200, 120, 28. Okay, let me write any number, no problem. And then 00. These are the internal IP. But the entire company can be defined by just one public IP. This public IP is, is used to surface the internet for the internal employees here. All devices inside the network see only one public IP. They can surf the internet using that public IP. There is some kind of mapping between the internal local IP and the external public IP. This mapping is done using the NAT. We have here local IPs and we have only one public IP. NAT is responsible to transfer the local IP to public IP and vice versa. For example, if packet coming from the internet and I want to deliver it to a computer inside the company, NAT is responsible to deliver the data from outside to inside the company. About DHCP. DHCP is Dynamic Host Configuration Protocol, and this protocol, before having DHCP, it was very difficult for engineers to make IPs for each device on the network. They have to do that manually. You have to do it manually. They can go to each PC and write the IP number manually. But now DHCP makes this process easy to assign IP for any device connecting to the network automatically. There is no need for doing it manually. This is DHCP. IP version 6, it is 128 bits. But the IP version 4, it's 32 bits only. This is 128 bits, so it is very large address scheme, very large address space. It contains 3.5 udecillion addresses. I don't know, maybe you can search the internet to know how this is 10 to the power what. It is very large number. And the benefits for the IP version 6. IP version 4, I have an internal IP address and external IP address. There is NAT, but for IP version 6, you can say, whenever I want to connect somebody, I connect them directly. There is no need to make NAT or mapping. So in IP version 6, it's a peer-to-peer network. Peer-to-peer network. For example, I am here in Saudi Arabia. I'm connecting to you using IP version 6 means that I'm connecting to you directly as we all on the same network. But for IP version 4, I have my local network, which has different IP address space, and then I have my house router. It moves the data from inside the house to the internet, and you take the data from the internet and do the opposite way around, taking the public IP address to the internal IP address to be able to see this lecture. For IP version 6, it's a peer-to-peer network. So people concerned about the security of IP version 6, but actually scientists that designed the IP version 6, they designed an internal or built-in security capability. They did the security and encryption built-in functionality. That's why maybe somebody asking you, which is better, IPv4 or IPv6? You can answer, it's all about the security functionality in each one of them. Maybe you can see IPv4 is more secure because it isolates the network, the company network, in a separate address space. And IPv6 is dangerous because this is peer-to-peer network. Means if a hacker can reach you, he will reach you directly. That's why there is a struggle between people when they think about or they talk about IPv4 and IPv6 security. IPv6 address is written in hexadecimal format. As you can see here, this is hexadecimal. It means from 0 to F, 0 to F. A is I think 10. Yes, A is 10 and B is 11 and C and so on. You know the hexadecimal address space. This is an example of IPv6 address. This address is very long and maybe we have to compact it a little bit. For example, if you look at these two, okay, let me point. If you look at these two zeros, I can compact these four zeros into 1 0 here for that one and 1 0 here for that one. I compact the IPv6 to make it smaller than this. And also you can, if you have two ranges of this, for example, you have a range of zeros here and, for example, a range of zeros here. But we don't have in this example. But anyway, imagine that you have two ranges of zeros. You can remove one of them and put 4 columns, 4 dots, or 2 columns like this. So you compact all the zeros here, this range, you compact it to that 2 columns. Okay? And also you can remove the leading zeros. For example, in this number, you remove the leading zeros. All leading zeros you can remove, but you can only have the double columns here for 1 time. You cannot have it 2 or 3 times, just 1 time. If you have it more than 1 time, maybe you will not be able to decompress. If this is compressed division, you cannot decompress it back to its original state. Okay, so this is IPv6 and how you, this is for, of course, just for engineers to be able to handle the IPv6 when they write documentation or write something, they write it in a compact format to be able to handle it very easy. Okay, I think we passed all of this.
Okay.
Yes. For the physical layers, we have some protocols in layer one protocols like synchronous optical networking, and these are services like digital subscriber line. These are protocols used in the physical layer, like T1E1, integrated services for digital networks, ISDN, Ethernet physical layer, and Bluetooth, and 802.11, this is for WLAN. These are protocols used in the physical layer. Okay. For the objectives, we can pass by the story of transferring between or transferring from wired to wireless from historical point of view. For example, in 1985, the FCC as a Federal Communication Commission, they are responsible for the radio spectrum. They are responsible for radio spectrum allocation. before 1985, nobody can have the radio spectrum without a permission. But after or at 19 or in 1985, FCC released some free of use radio spectrum. For example, if you want to make a device like remote control for your AC or remote control for your TV, before 1985, this is not allowed. But after this decision, this is a very important date in the wireless communication history, 1985. Because FCC released some free bands. Anybody, any factory can use these free bands. For example, I can have a remote control. I can have microwave device. I can have, for example, I can have Wi-Fi. Wi-Fi is also used in the unlicensed use. There is no license. There is no need to have a license from the government to be able to use these radio spectrums. You can use them directly. For example, the first time they have that decision, they released 3 bands. The first one, 900 megahertz. The second one is 2.4 gigahertz, and the third one is 5.8 gigahertz. These 3 bands are used for free. There is no license. Nobody can ask you about a license for these bands. Companies started to adopt these frequency bands to make, for example, cordless phones. They start to make cordless phones, like wireless phones. The cordless phones is not cell phones, as you can see it right now. It is used in the army. It is one channel, not half duplex, if you know about half duplex. So if you want to talk to somebody, you can say, oh, hey, I am here. While you say, hey, I am here, that one who is listening to you cannot speak. Even if he is speaking, you will not hear him. He should wait for you to finish and then he can start. So it is one-way communication. It is used in the army. It is one-way communication. You cannot speak, you and the other terminal at the same time. One speak, one hold. One speak, one hold, and so on. This is cordless phones. The unlicensed bands are used to do the cordless phones in the army, and the remote control, for example, the ceiling fan and even wireless networks. And that's why we want to concentrate on those unlicensed use radio spectrum, because we are going to use them in the wireless networks. After a while, now FCC told us, okay, you can use a free frequency band. Now companies started to study how to make a wireless LAN. IEEE in 1990 established a working group to create a standard for WLANs. They created that standard at the beginning in 1997. That standard for communication. I told you about the standards. What is standard? Is just to have a protocol to communicate between wireless devices. This protocol can be implemented by software and hardware. So they start by 2.4 gigahertz and developed that standard year after another. Even after that, we have different versions of 802.11. We have 802.11a, 11b, 11g, and 11n. Okay, these are the standards for the wireless network protocols, and it is created or designed by IEEE in 1997. Okay, it's time for you to have this activity. Can you read this activity and tell me the answer? You learned about the FFC or FCC groundbreaking decision in 1985 to open several bands of radio spectrum for unlicensed use. Which of the following is not true regarding the effects of that decision? Initially, WLAN users were far more interested in performance than convenience. Manufacturers poured millions into research and development, which improved performance, which in turn attracted more users. Anyone could use, you have to get the odd one, the not true one, so to take care. Anyone could use WLAN as long as the transmission power was kept low. Eventually, WLAN performance was boosted to 2 megabits per second, a 400% improvement. What do you think?
Doctor,
Doctor,
it's the
I
last
think
one. Last one.
three, third.
Yes.
Fourth one.
Abdullah is saying the last one.
No, Doctor Abdullah. I'm
Ahmed?
saying third.
Abdullah Ahmed, okay.
Abdullah Ahmed, I'm saying third.
Third one. Anyone could use WLAN as long as the transmission power was kept low.
I'm rethinking, Doctor.
Okay. Of course, you can use WLAN as long as you have a transmission power low. Why transmission power must be low? Just because not to affect other transmissions. Because if you have your power is very high, you will affect other transmissions. Nobody in your neighborhood can send or receive on the same wireless band. That's why that third point is very important, because there is some kind of attack. The hacker has a device and send with very high power transmission. If you send with very high power, you will not be able to send or receive. So this is some kind of attack. You have to keep your power low to let others send on the same wireless band. So this is true. And this is also true. Eventually, WLAN performance was boosted to 2 megabits per second. That was the beginning. 2 megabits per second was the beginning of WLAN. Manufacturers poured millions into research and development, which improved the performance. Yes, actually, this happened, which in turn attracted more users for WLAN. So the first one is the odd one. WLAN users were far more interested in performance. Of course, no. They were interested to have just wireless device. They were happy about the wireless device. They can talk at any place at any time. They were happy about that, even with low performance.
Doctor, they were convenient about it.
Yes.
Like that's something that this thing is available.
Yeah, they were happy that this thing is available. For the first time, of course. That was very happy days for them. They don't care about the cut in the voice or the noise in the background or the latency or throughput. They don't care about all of these performance measures. They just care about, oh, okay, I can communicate with somebody, even if it is very bad, but it's okay. I can communicate with him while I'm traveling, while I'm in the desert, or even traveling to any place. Okay, so this is actually in the desert, you will not be able to communicate unless there is a tower for the wireless network. So okay, so the answer is the first one. Okay, I think we have okay, let's have another 5 minutes or 10 minutes, and then we can take a break.
Okay, doctor, okay.
The economic impact of wireless network. Okay, and the economic impact was just, you see, at the beginning, the people was the people at that time was very happy regarding the existing of that new technology. So, for example, the companies started to have internet services at a cafe and shopping malls. So they started to introduce free based services, just to make people, to attract more people to their malls or to their markets. Also, the high-speed ADSL and broadband fixed line networks became common in residential properties. So started to have ADSL that boosts the transmission of wireless access points. Also, the ISPs often supplied Wi-Fi enabled gateways. As you can see now, if you take a router from the company, for example, here in Saudi Arabia, you have Mobile and STC. If you want to apply for ADSL or something, you take a router, wireless router, actually. At the beginning, they started to give not landline router, but wireless router too. So the Wi-Fi was there and embedded into the routers from the ISP, from ISP companies. About the technology, okay, just give me a second. I want to revise this part with you. Okay, yes. So wireless network entered the business heavily for these sectors like healthcare, warehousing and logistics, retail, and general business and knowledge workers. For the healthcare, there are real-time access to patient records. For example, before that wireless network, the data of the patient is written on the bed tail or something at the beginning. Whenever the doctor came to the room, he can see that handwritten thing. But this handwritten thing was a disaster because maybe teared or spoiled with water, anything can destroy it. But now we have a real-time access to patients' records. If you have a wireless cell phone, you can open the hospital application and see a real-time data of that patient. The devices on his body transferred data to the database of the hospital application, and you can see this data on your cell phone directly. Real-time data, okay? That's why healthcare is developed in this for real-time access to the patient records. And also patients can always be monitored. We can monitor patients using the wireless devices. Also, the wireless devices, at the beginning, we cannot move devices with the patient. But now, if the patient want to move from the room that assigned to him to the operations room, he can go and the devices go with him. Okay, and for the warehousing and logistics, there are many applications for wireless, or many benefits for wireless networks there. For warehousing, you can, for example, count how many objects inside a warehouse. And also for logistics, you can capture how many how many objects came to your warehouse and how many objects came out of your warehouse. And also with the invent of wireless network, there are GPS. GPS enabled the tracking of packages and cars. So logistics used the wireless network heavily after that. For retail, you can have an inventory count. For example, before doing that, you have to carry all whatever inside the warehouse and go, or the store, and go to the device to count how many objects of that specific good. But now you can go with your wireless device inside the warehouse or inside the store and count how many just by reading the barcodes. And also for user satisfaction or customer satisfaction, whenever you go to the mall and you have a problem, you can have a guy or a boy over there standing with his wireless device. If you ask him about the price, if you ask him about how many items are there, I want to buy something, it is there or not, he can give you an answer directly. So it was very useful in retail for 2 points: for inventory counts and for customer satisfaction. And in general business, there are knowledge workers. Knowledge workers are the workers that have knowledge about computer networks or computer PCs or computer maintenance. They care about computers, not just, for example, the accounting department. They have computers, and those guys started to have knowledge in computer maintenance and computer application installation and so on. They start to have to affect the personal life of knowledge workers. For example, as I told you before, when you go to your company, you have 10 hours or 12 hours work, and then 12 hours are too much. Maybe 8 hours is okay. So 8 hours work and then go to your home and just forget about work and enjoy your life with your family and family members. But after the invent of wireless network, there is no border to separate work life and personal life. You can take your device from work to home and from home to work. You can work even 24/7 hours. Okay, that's why knowledge workers was very happy at the beginning that they have this kind of devices, but after that they see it as a disaster for them because they don't have a personal life now. In any time, his boss can call him at any time and tell him to make an order or to withdraw something or do a transaction on the bank or whatever. So there is no separation between personal life and business life. Okay, I just want to ask you a few questions to make sure that you understand the subjects, and then we can have a break, okay?
Okay, Doctor.
Okay. There is a Federal Commission or Federal Communications Commission, FCC. What do you know about FCC? What they have done? Anybody knows?
Doctor, the Federal Communication is an agency in the United States that is independent. It performs regulations by the radio and television.
Yes.
If this is actually what you mean, I think it's in the United States.
They have a very, very important decision at 1985. Any other guys there can answer this question? But Abdullah Isam, Shayma, Nadine, Haneen, Abdullah Ahmed, Firyal, Hagar, Haneen, Nurhan. Do you know the FCC decision? That decision at 1985, they said or they released something. They said something. They have a landmark decision for wireless network. Anybody knows the answer? Okay.
Doctor, I think
Yes.
they said that now we can communicate through large distance, either by WAN.
Yes, Abdullah Ahmed, you are near the answer. You are near. Okay.
Okay, Doctor.
And
Let me just think.
okay, so it's for the FCC. They released free of use wireless bands. At 1985, they released those bands for free of use. There is no license to use them. You don't have to apply for license to use these bands. For example, if a company making a TV, they want to have a remote control for the TV, they want to use the wireless band, they have to make a license from the FCC. But now, after 1985, they don't have to go to FCC and have license to use that wireless band. So before you have to use to have a license, now you have free bands. And I told you about these free bands, 900 megahertz band, 2.4 gigahertz and 5.8 gigahertz. These three bands are used for free. Anybody can, without any license, unlicensed use of wireless bands. Okay. Okay. Yes.
No, okay.
Okay. Okay, last question, and then we have a break. What is the function of network layer in the OSI reference model?
Doctor of network layer?
Yes.
Doctor, can you repeat the question?
What is the function of network layer in the OSI reference model?
Doctor,
Find the best route to send the packets from sender to receiver.
Yes, Harry, exactly.
Control the operation.
Control what operation?
And to control the operation, what's happening in the, like as Hajar said, like to send packages from one place to another.
Yes, you can say that, but this is not the functionality. Is not its functionality is other layer functionality.
Doctor,
Yes.
it permits different networks to be interconnected.
Yes, exactly. I think Nurhan, you studied networking very well. That's we didn't say that in our lecture today. It's very it's very important. Routers can have the ability to, can provide an ability for different LANs to connect together. Different types of LANs. I mean, for example, with different address space, they can communicate. Router can do that. But the network at network layer, the responsibility of network layer is to have the best path for the package to route from or to pass from terminal A to terminal B. Okay.
Doctor, can you repeat it again?
I mean, for network layer, the most important functionality of network layer is to send the package from, or to find the best path for the packages to come from or to go from terminal A to terminal B.
Doctor, it's only one packet, صح? Not entire.
Yes, they care. Yes, Ferial, exactly. They care about only one package.
Only one, yes, not entire.
Not the entire package. The one who is caring about the entire packages, the entire collection of packages.
Transport.
Transport. Yes, they serialize the packages
Yes.
at the sender and assemble them back at the receiver.
Doctor, can
Yes.
you like briefly tell about the data link again, please? It's responsible for what?
It's responsible for preparing data to be sent to on the physical layer. For example, the coding and decoding and the error checking. Okay. The coding and decoding means,
Doctor,
yes.
let's check for the sender and receiver, صح?
What?
It's a check error for the sender and the receiver.
No, for the data, for the frame, for the data itself.
Decode data to be sent from in the physical layer.
They code, yes, they code at the sender. Yes, exactly, Hagar. They decode the data at the sender. They code it at the sender and decode at the receiver. Do you know what is decoder, encoder and decoder? Do you know about them? Encoding and decoding.
Doctor, you told encode data at the sender and decode it at the receiver?
Yes. Okay, so let me have an example for encoding and decoding. For example, if I am talking to somebody, I want to have a message in my mind. The message is printed on my mind like electrical signals on my brain. That message, I want to deliver it to somebody. What I am doing, I am converting this signal or electrical signal from my brain to sound. This is the encoding, means is changing the type of data to be transferred in the media. It is electrical signal in my brain. I want to make it to send it to my receiver or to the receiver to be delivered to him in his brain as electrical signal too. But this is not going to be done with, for example, copy and paste. For example, I cannot copy whatever internally in my mind and have this copy in his mind. No, the only way is just to communicate this. Communication means to change the electrical signal in my brain to sound with my mouth. And then this is, a mouth is a device that makes the encoding. And the opposite way around at the receiver, there is an ears. The ears takes the sound and convert it to electrical signal to the brain. This is the decoding process. We do the same in the network. We do the same thing in networking. For example, I have my digital data. I want to transfer it to another person or another terminal using Wi-Fi. The Wi-Fi is microwave or radio waves. I have to change the digital data to waves. This is decoding, this is encoding at the sender and decoding at the receiver. Okay, you understand now what is the difference between decoding and encoding and decoding? Should I repeat again?
No, it's converting normal human language to zeros and one.
Yes, you can say that.
So that
it converts whatever the data to a form that can be transferred in the media, whatever media you have.
Oh, okay, doctor.
So you have
Okay.
an air media. Yes, exactly, Abdullah. Abdullah Ahmed, exactly. You said exactly, but it's in the media. For example, air. The air is a media. I want to transfer data in the air. So the only way to transfer or to change my data to something can be moved in the air. I want to send it in fiber cable. I have to deform my data to be able to be transferred on the
Go
fiber.
to fiber. Okay. Okay,
Yeah.
doctor. Understood.
Okay, so I will take attendance just a few seconds, and I will take the attendance.